Hi, this is Dr. Hamilton. In April, I had a conversation with some of my Omega brothers at a breakfast. We meet monthly for breakfast, and had a long talk. That had a conversation and a presentation about artificial intelligence. Why it matters and why should you care. So I thought I'd share a little bit of what I discussed with the brothers and the questions that they asked were so intriguing. It led me to kind of represent this in social media. So I started out by talking a little bit about intelligence itself. Instead of getting into artificial intelligence, I said let's just talk about intelligence. So I mentioned that it's cognitive, emotional, and social. Um, and so when you look at some of the earlier definitions of AI, it was described simply as just computer programs built on top of machine learning, deep learning, and large language models. I made a point during the presentation to talk about how data grows up to be information, and information grows up to knowledge. And one would hope that eventually turns into expert systems, but the jury's still out on that. So I took a bit of digression to look at some of the traditional learning modalities like reading, writing out words again and again, rewriting your ideas and principles into other words, oral learning, attending lectures, use of tape recorders, summarizing your notes. Those are kind of old school. Visual, though, I leaned on a bit. Uh, I guess somewhat because I'm a visual learner. But if you redraw pages from memory, if you replace words with symbols, practice turning visuals back into words, those are kind of the visual learns. And then kinesthetic uses all of your senses. So think about that. As I continue to talk about generative learning, reading, highlighting, and generating questions, I moved then into being more adaptive and adaptive. Okay, what I call deep learning. I work a lot with doctoral students, so that's where we are. They're in the inquiry side of learning. And adaptive intelligence, most of the scholars I have looked at are like James Marsh, Gary Hamel, or Prahalad. And then lately, I've been looking at a lot of cognitive networks. So let me just roll back in time just to make sure that everyone has a sense of what AI is, because that was one of the major questions during my conversation. So I took it all the way back to 300 BC when the desk abacus was first invented, and then fast forward to 1800 BC when Babylonian mathematicians developed algorithms to resolve problems. And then as we got to 500 BC, the bead and wire abacus originated in Egypt. And a lot of void happened. The next major milestone that I took of note is 1622 when William Althred developed the slide rule in England. And in 1642, Blaise Pascal built the first numerical calculating machine in Paris. All right, so let me highlight a few key names, though, that I thought are more recent and more effective. I'm going to start with Thomas Bayes. Thomas Bayes. He developed a framework for reasoning about the probability of events. So if you've taken statistics classes, you may have remembered Bayesian inference. Uh, he became a lead. His work became a leading approach to what we call machine learning later. That was followed by Isaac Asimov, 1942. He published a book called Runaround about robots. So he actually inspired the American cognitive scientists like Marvin Minsky, and later the Massachusetts Institute of Technology AI laboratory evolved out of that. Okay, so a few years later, about 8 years later, Alan Turing had his input. He was the English mathematician, and his contribution was he published a book called Computing Machinery and Intelligence, and that opened the door to the field that we now call artificial intelligence. So, so the actual term then was coined in 1956, right, to capture the abilities of analytics, decision making, and learning. All right, and it was pretty much in the wheelhouse of computer science, the study of intellect. Okay, and it brought in at this point now philosophical and psychological perspectives. Right, so the growth was really accelerated. And I also want to highlight another famous scholar, Dr. David Blackwell. He was an American statistician and mathematician. He had numerous contributions to game theory, probability theory, information theory, and he wrote, series of theories with others. All right, so that brings us to today's time and OpenAI. So OpenAI was really first conceived in 2019. It actually a little before that, but in 2019 it transferred from its nonprofit beginnings and became a for-profit entity. And in 2020 they launched GPT-3. All right, and eventually in 2022 it previewed the Chat GPT, as a chatbot. All right. So let's talk about ChatGPT just a bit. My nickname for ChatGPT is the Swiss Army knife of modern productivity. Okay, it's always here's a good uh, visual. Okay, it's always available friend, endlessly patient, and provides insights on a variety of topics. Okay, what a friend. All right. So the reason I brought Dr. Blackwell in because NVIDIA, the company that accelerated calculations, GPU calculations, and helped for a lot of the movement into ChatGPT, has released in 2025 NVIDIA Blackwell architecture, new class of AI superchips named after Dr. David Blackwell. Very, very impressive speed now. All right, so a field within artificial intelligence is called knowledge engineering. Some of you may have remembered my sin back in the day. So that was like 1978. So knowledge engineering transfers human expertise into computer systems, right? So if I were to walk through a supply chain, it's knowledge acquisition, knowledge presentation, knowledge validation, and then integration and reasoning. Okay, knowledge engineering. So very powerful subject, especially for those of you who are students that are thinking about specializing in AI. So I would say that the most popular pre-trained AI or ChatGPT, then of course, and then Cloud and Gemini. So I'll leave it to yourself to learn those. And there's some other chat bots like Perplexity, Meta AI, Ideology, Copilot, Replica, DeepSeek. There's a few. So what are some of the famous use cases in generative AI? Well, some that come to mind are like nutrition, meal planning, health, wellness, parenting, relationships, travel, entertainment. But when you look at the use cases that have found themselves in the business, at the top of that list, uh, sorry for the phone, at the top of that list is fraud detection and security analysis. So, you want to study that a little bit. There was a study done of a little over 800 decision makers globally, and these were like companies making over 100 million, about 250 employees. So they found that 65% of the activity was fraud. So I mentioned expert systems earlier, collection of rules which assume that human intelligence can be formalized and reconstructed in a top-down approach. Basically a series of if-then statements. And I'm not sure how comfortable I feel about that. When I look at my uh, definition of expert systems as programs aimed to model human expertise, Why does it have to be top down? Why does it have to be top down? The technical definition of expert systems says that there are three components: a knowledge database, facts, rules, human experiences; an inference engine, I mentioned that earlier; and an I/O interface for user interactions. That's the important missing component, as I see it. That's the important component. So their research also found that 41% of those companies surveyed felt that AI is central to long-term business planning, but only about 34% of them report that they're actually working on something right now. Okay, so let me give you just a few definitions then. So that's generic AI mostly, but then there's something called agentic AI. It's just agent with an IC at the end because it acts like an agent. Okay, but it understands an objective. It can plan how to achieve that objective, and it can take action, often across multiple steps, and it can adapt based on results. All right, so the reason I think that definition is important because 2026 is the era of agentic based cyber attacks. Cyber attacks. In other words, identity is the new exploit. And one other important component of AI, classification of AI, is autonomous AI systems that operate independently, making decisions, taking actions without human oversight. So examples would be like self-driving cars, autonomous drones, used a lot in logistics and defense, industrial robots in manufacturing, etc. All right, so all of these heuristics are useful, but they can lead us to misguided judgments. If you're new to AI, that's important. About 27% of chatbots hallucinate. Factual errors show up in about 46% of generated text. So if the question in your mind, if this question is in your mind of what makes artificial intelligence smarter, you, right? You cannot remove the human from the process, right? Information and in particular the ladder of inference I mentioned before goes all the way from observation to selecting to creating meaning and taking assumptions and drawing conclusions and adopting beliefs and then taking action. But a lot of that is perturbated and crafted and collaborated with human interaction. All right. And so I'm going to end with this bit of reality. There are about four AI companies that are spending almost $700 billion on data centers. This is 10 times greater than what we spent to circle the moon, the Artemis launch that flight that we all enjoyed a few weeks ago. Okay, 100 times greater than the money we spent on that. So there are economic inputs, impacts, political impacts, mobility impacts, healthcare impacts, security and defense impacts, and environmental impacts. So I read a quote that I'll finish this conversation with. It's kind of interesting. I won't share who the quote came from. It's not terribly important. But it says, in the future, human employees will be increasingly occupied with the feeling task, since thinking tasks will be taken over by AI systems. All right, so I hope you enjoyed listening to all of this. Hope you learned something. I am Dr. Hamilton. Thank you so much for listening.